Hello and welcome to the Analog Devices Precision Digital Isolation Technology training videos on the fundamentals of isolated gate drivers. This video is the sixth in the series and will focus on key gate driver applications and topologies. The isolated gate driver offerings from ADI can be classified into three categories: performance, protecting, and programmable. Performance gate drivers provide basic functions such as high drive strength and under-voltage lockout option, UV-LO. Other standard features are low pin count, small footprint, low delay, and high CMTI. Some of the performance gate driver offerings are the ADUM4120 and ADUM4121 and the ADUM4220. Only basic protection may be provided, such as dead time protection or gate sense for Miller clamping. Typical applications include onboard chargers, OBC, and DC to DC power converters. Protecting gate drivers provide features in addition to performance gate drivers. They have a higher pin count, but still provide low delay and high CMTI. These drivers have an integrated protection or monitoring functionality and have a backchannel for error reporting. These drivers may also have an overcurrent or DSAT protection. The ADUM4135 and ADUM4136 are some of the products in this category. Typical applications include traction inverters and industrial or energy systems. Programmable gate drivers provide the most of all the available features. They do have the highest pin count, but similar low delay and high CMTI as other driver types. These drivers have an integrated protection or monitoring functionality and several backchannels for fault or status reporting. These programmable drivers also have functionality for temperature sensing and control for secondary side power. Some also have the provision for a SPI interface for user programmable settings. The ADUM4137 and ADUM4138 belong to the programmable gate driver family. Typical applications include traction inverters and high-performance industrial or energy systems. The ADI isolated gate drivers mentioned previously are all designed to work with IGBTs and power MOSFETs. The drivers provide enhanced control and monitoring for these switches. For large power devices, these gate drivers provide high drive strength for quick charging and discharging. The isolation within these drivers is able to withstand high voltage across the barrier reliably. ADI's solutions offer the highest performance for existing IGBT or MOSFET applications, while delivering the most robust solutions for emerging switch technologies such as SiC and GaN. The drive requirements of SiC switches is high CMTI and high drive strength of the drivers due to the faster operation of these switches. The withstand time of SiC devices is lower than IGBTs, and hence for safe device operation, faster response and lower delay is necessary, which is also supported by ADI drivers. Overcurrent protection schemes for these devices are also different from IGBTs. The requirements for driving a GaN switch aren't too dissimilar to that of the SiC MOSFETs, except that the gate-to-source drive voltage requirement of the GaN switches is generally lower than the SiC switches. Due to the even faster switching of GaN, having the compact size of a gate driver and drive layout is important for robust operation. High CMTI and low delay are essential for driving these switches too. These switch technologies and the ADI isolated gate drivers find applications in energy markets with a focus on PV inverters and storage. They are also commonly used in industrial motor drive applications. Several of these isolated gate drivers are automotive qualified for use in EV, HEV chargers. This block diagram illustrates a traction inverter which is used to drive a motor. A half-bridge circuit may be used for each phase in the traction inverter system, and it may be designed using IGBTs or SiC MOSFETs. Several gate drivers would be used to drive the switches in this topology. Since there is a microcontroller and other mixed-signal circuits, isolation becomes necessary in such an application to keep the low-voltage electronics and the high-power components separate. Thus, isolated gate drivers likely have some protection features, such as DSAT detection, and a Miller clamp could be used here. Other applications, such as EV, HEVs, also have a separate inverter for regenerative braking. Inverter system power levels may range from a few kilowatts to hundreds of kilowatts. The figure shows a block diagram design for driving a silicon carbide SiC half-bridge module. This design consists of two ADUM4146 isolated gate drivers to drive each of the switches in the modules. The ADUM4146 is a protecting gate driver with bipolar supply, Miller clamp, and desaturation protection. The secondary side is powered with an isolated supply with a plus 15 volt and minus 3 volt rails. The board has a circuit for temperature measurement of the module, along with some additional linear regulators and other supplementary components. As previously discussed, this topology is a basic building block in a variety of circuits, including a buck converter. Analog Devices has many digital isolators that provide trusted safety and data integrity. To learn more, please visit analog.com/iCoupler.